So, thank you for coming. I still have a bit of jet lag, so if I fall asleep here, just notchly give me a little push and I'll wake up. Or, yeah, you'll be gentle. Yeah. So how many people in here have not ever heard of functional programming? Usually helps if I raise my hand. We got one. Okay, who's heard of functional programming? All right, and who has more than heard of it, actually used it? All right, all right. Who's used it on a real project, like a commercial project? You have. Very good. All right, so one of the challenges with doing, one of the challenges here is to use doing functional programming in a dysfunctional programming language, such as Java. So there are things we can do and there are things we can't do. But, so let me start out so it seems like most people have a pretty good idea what functional programming is, but let's just go through a few things here. So in functional programming, the main abstraction is functions, most of the time anyway. And we sort of think of computation as evaluation of values. And if you're a little fuzzy on that, that's okay. It'll come back to haunt us later. The going model here is the simplest computing model of all models. It's the substitution model. So everybody does, okay, how many people in here recognize those words, substitution model? All right, 3 people, wow, okay. So, let me give you an example here. Over here we have sort of the definition of a couple of, let's just call them constants here. We set them to a certain value. And then I define a function, which is also constant, does not change. And then I sort of, I write up this expression. Now what can happen here is one of two things, or a multitude of things, but at least 2 things. We can either expand this out or substitute in A and B, giving you this, or we can substitute out what the function means, meaning this, and then substitute in the A's and the B's. And no matter how you do this, you end up with the same result. And I think it's 23, but check.
It's not 42?
Unfortunately, I should have picked some other constants. All right. So one of the tricks here is that there are no side effects. These are functions in the mathematical sense. You put in some numbers, you get some numbers out. You put in some values, and you get a value out. If you need more than one, you put it into some kind of collection and get it back out. But that's it. There's no other things, no other magic going on at the time. So this has the advantage that it avoids state and what we call mutable data. And if that's state, most people understand. How many state are with me on that one? Okay. Mutable data, how many get that one? The same 5 people, good. So some people have described functional programming as more of a sort of saying what to do as opposed to how to do it. And you'll see why that sort of comes up. It's not, there's no good, actually there's a good reason, there are many good reasons, but it's not sort of apparent until you get into it and you'll see how elegant this is. So let me compare that to imperative programming, programming as we know it in Java, where it's essentially, we have a bunch of action statements or procedures that produce effects. And they're state, because that's the effects that we cause. And this comes out of an idea, and let me just say I have the deepest respect for both of these gentlemen, but that models have worked great for the last 50 years, and now it's beginning to show some sign of age. So the Turing machine and the von Neumann architecture essentially says we have a processing unit and we have a storage facility. And what we do is that we read in stuff from the storage facility, process it, and put it back. And that has the side effect that as soon as you have more than one thing going on, even sometimes when you only have one thing going on, because sometimes you confuse yourself, you can actually incidentally or intentionally change something that another, let's call it process, was relying on. The classical example is the global variable that everybody uses. And somebody accidentally changes and your program stops working and nobody can figure out why. Right? How many recognize that situation? All right. Good. got that in there. So, one of the first problems in the old school of programming, or in the von Neumann type, is assignments. So here I've written up a little program. This actually, I used to, and sometimes I do, and hope to again, teach at a little technical school up in Del Mar. And one of the students actually wrote almost exactly this piece of code. And I was sort of puzzled why he would do this, and he sort of explained to me that it was because, well, I need to execute something. It has to do something. So the first question is, what's the intent behind this code? What is he trying to do? Anybody?
Test.
What do you say?
A test.
Okay. Anybody else?
Determine the value for B.
Yes.
It's just
Little further. What's he trying to?
A equals X.
No. This is not. What he's trying to do is to assign a value to B. Yeah. That's what he's trying to do. Right? And I am glad that none of you hit upon it, although you came close. Because that is exactly the problem. It obscures this type or this style of programming obscures what you're trying to do. Right? The intent here is to assign a value to B. The problem is that we're sort of introducing what is known as incidental complexity. There's two kinds of complexities in this world. The one is the inherent or essential complexity of a problem. Here is, which is to find out a certain test and then assign a value accordingly. And the other one is the incidental complexity, which is what are we adding in that's not really necessary to understand or solve the problem, but we have to add it in order to execute or find a solution. Right? So in this case, whenever we run this code, we're only gonna run, or only one of the assignments is gonna execute, but we have two of them. Clearly, we have introduced something that's more complicated than it needs to be. You with me so far? Good. So let me give you another example of incidental complexity. Can somebody figure out what this code is supposed to do?
Find 42 in the list.
Bingo. Exactly.
On the
And then,
index of 42.
yes. So which I presume is what you meant, but I've looked at this for a long time, right? So essentially, it goes through the list, finds. Did you hear this already? It goes through this, blah blah blah. So it finds if there's a 42 in there, it remembers what index it is, right? So in this, to do that, right, we are introducing a variable called found. We're introducing a variable called index. We are executing the length of the list. We have some adding to an index here. We have a for loop, and we have a break, all of which have nothing to do with the problem whatsoever. They're all there as something that helps to execute some code to get us to a solution to the problem we're looking for. Okay, so this is old school. In Java, of course, we have the new version of 4. Doesn't really solve the problem per se. It helps, but it doesn't quite solve the problem. And I'll show you later how we can actually do all of this without any for loops whatsoever. Think about that for a second. If you use this technique, you will never have to write another for loop in your life. Almost. All right, back to the assignment. So, the problem here is that if is a statement, meaning it says something about execution, when in fact it should be a function. So, if we could write b equals something, we're now making it clear we're trying to assign something to b, and also from this, you should be able to tell what's going to happen. So question is, can we in Java construct a function that takes a Boolean expression and an object and returns this one if this is true and this one if this is false? Is this possible? All right, one at a time. Who said yes? All right. How do you think we can solve that problem?
Write a ternary if statement.
That is exactly right. It's already built in. Right. That's what that looks like. And not only is this shorter to write, it's also shorter to read, but it perfectly frames up what he's trying to do. There's no doubt here. The intent is preserved in the translation into source code. And go ahead.
chosen the example not very well, because you could just say B equals A equals Z.
Which is
Okay.
right? Which was the second problem with this particular student. He hadn't quite grasped what this is, and that it's just an expression that can be evaluated, and that value can be then stored in there. So you see this? So this is the first of three things I'm going to show you about how can you do functional programming. So instead of using if statements, whenever you can, use one of these things. It'll make your life easier. All right, typing. And those of you who have heard me wail on this, consider yourself excluded from this conversation. So consider these two programs and tell me what differences there are, if any. And I'll give you a couple of minutes, or maybe a minute or so to figure it out. But think about it for a second. What are the main, if any, differences between these two programs? Take a second to think about it. When you think you have something, like give me some kind of indication that you're onto it.
The first part here is a class Boolean, the second one is primitive.
Yeah.
So you could
But
get,
that's kind of what I'm saying in the headline.
Yeah.
Right, so it's a little deeper than that, what I'm looking for.
so you could get a kind of a null pointer calling the first method, but you could get a null pointer inside of the second method.
That is exactly right. You're exactly onto it. Oh, Brian.
Sorry,
So the first thing, anybody else has any thoughts on what the difference is here?
The left one returns, speaks in Spanish.
Exactly right. And there is no nom in French or whatever.
It's nul.
And I was kind of, yes, exactly. It sounds French, right? All right. So the line of thinking that I was kind of hoping somebody would go down is this idea, well, all right, so we get to the bottom here, it says return null. But over here, we're returning a string, and over here, we're returning a string. In other words, that string is always a string, but this string can be null. So the type of this function should really be string or null, as opposed to the other string, which will never be null. All right. Well, so, which is your point exactly right. So we've seen the or null here, which means this one, the Boolean, can also be or null. Right? And it would be nice if we could sort of say that, because the Boolean over there can't be null. And the type system understands that. Right? But in this case, it can be null. And of course, if it's null, what happens?
It works fine.
Yeah, it works fine. Yeah, exactly right.
On a pointer,
Yeah, but where?
right on the B2 equals true,
Yeah,
right?
yeah, and why is that?
Because you can't call an operation on a null.
Exactly. So I'm not exactly sure what the compiler does, but if it's trying to unbox it, there's going to be a problem, right? Yeah, because it's not. All right. So the solution to this kind of situation. So let me just first of all let me just make this clear. This is a horrible, horrible, horrible situation. How many of your programs have you actually thought about that you could get a null passed in, or you can return a null? And how often do you actually check for that? All the time.
Lots.
Yeah. But how many of you have a program running out there where perhaps there's just a couple of places where you didn't do that? Right? Okay, who's got more than a couple of places, right? Yeah, exactly, right? So this is no small problem, and I would venture to guess that the most common problem with Java programs is null pointer exceptions. Right? They happen, and you're like, oh, what happened? Right? So if we could tell, if we had a type system that would support us to say, this is string or null, or this is Boolean or null, then we would be much better helped. You with me there? couple of languages out there that actually does this now, where it will say string or null, and then you get to account for all of that when you get the calling sequence. But we're in Java. So there's another solution to this, which is called algebraic data types. Who has ever heard about these little critters? Okay, we have 3. Would you care to explain?
No.
No?
It's kind of like you have objects just for the non-pointers, like empty objects. But it contains empty. But it's pretty much just try to avoid the non-pointer exception. For me, I just start using it, but I didn't find it very useful so far.
Okay. All right.
Yeah.
Eric? No? Okay. So essentially, algebraic data types is this idea that we have a few sort of well-defined instances, and we have rules for creating them, and maybe transitioning between them. So the classical example is Boolean. It can be true, or it can be false. And how do you get between them? Negation. You can take one and turn it into the other. That's the simplest one. Yes, I think that would be the simplest one. Can you have one with one value? I don't know. Can you? I don't know. Whatever. Anyway, so the one we're going to use is called option. In some languages they use maybe, but essentially it's the same thing. So option comes in 2 varieties. The non-variety, which says we got nothing, and the other one that says we have something, and here it is. So I borrowed this from functional Java, and that's the library I'm going to be using going forward. There are some design decisions I completely agree with that they've done, and there are some I don't agree with so much. So in this case, you will get different instances, but you can compare them. So this class option is defined, and the T is, of course, you can have option string or integer or something else. And in that case, if you call sum on an object of this type, it'll return the value of T. Okay. So essentially, what we're going to do with this option thing is we're going to take a partial function. That is the function that sometimes returns null because it's not well defined apparently, and then make it a total function, meaning it'll always return a value, and we'll be able to, no matter what input we give it, and therefore is always well defined. Does that make sense? I see a couple of people nodding, some people look confused. Would it? Okay, we'll move along. So, have you ever seen a piece of code like this?
Yes.
Yeah. Okay. Who says no? All right. Yeah, because you just looked at one not 2 minutes ago.
I'm not raising my hand.
Right?
Bingo.
This is how common that is, right? It's right there. Right? What happens if there's no 42? Right? But because it's an integer, it has to have a value. It can't be null. So let's try -1. It's always a good one. I don't know why it's better than -42, but right. So not only is it so common, it's so common that most people don't even notice anymore, right? That's how bad it is. All right. So let me go forward to this. So this one, we're going to solve with this problem. We're going to say, okay, if we can't find it, we're going to return an option with none. We don't have anything, we're going to give you none. If it's an object, we do the same thing. The return type, of course, changes here. But you see the idea of how we put the return type we really want in there inside the option. Okay? So let me see if I can get into, here we go. So I haven't option here. So I have the other two you've already seen, these two. I just can't have too much on the screen at the same time. So let's look at created one like this one, but one that actually works. And I've just put in null here. And I've written a test for it. Let's see, here we are. The test says, we're just creating one of these demo things. It says, if we put in null, then we get back none. So the result that we get back, we can ask is none, and it'll be true. We'd also ask is some, and we will get a return value false. Now, if we put in something that's true, we should get back a string, and we go, so is some, yes, we have something, and what it is just some. This is one of those situations where in Java we probably say get some. Right? Does that make sense? Alright, so that's how we want it to work. So how can we make that work? And this is where it becomes audience participation time. Let me start out with something. And I'll remove this. So, what's the first thing we should do here when we get into this?
Run the test.
Yeah, we should fail. Trust me, it fails. Alright, so what's the first thing we should do when we get into this? So please note, I intentionally have not made this an option Boolean, which we could have, but because of because most times we'll get a Boolean from somewhere else, and then we'd have to wrap it up and that sort of thing, which we could do, which is actually not a bad idea now that I think about it. I should think about that some more. But let's just write it up. Let's say we get this call from somewhere that we're not in control of, and we need to be able to accept a Boolean object here. What's the first thing we should check for?
No.
Okay.
Couldn't you do like boolean.true equals B3 to avoid auto boxing?
You could do that. Let's do this first. So if B3 is null or
false.
false. Yep. Exactly. Then what?
Option.none.
Some.
Is it like,
There it is. Okay. And in the other case, or
return option of M2 of B3.
Return some, yeah.
and what's the argument?
M2 of B3.
I'm sorry.
M2 of B3. No?
Yes, you could do that. You could call M2 to get the value that you wanted. I'm just going to simplify this just for the sake of presentation. So in here, we put in the string.
Okay.
If I can spell it.
So the test's in yeah.
Is that right?
I didn't see.
Yeah.
No, it's right above, right? It's M2. So do we think this works?
Show us the test, please.
Save this. Alright, so here's the test. Let's just see if we can run this. How many thinks it's gonna work? Yeah, I'm good with it too, but I could be wrong.
Oh, yeah, not we.
So what's the problem? So, yes, I'm sorry, you're right. We should have had changed that. Or maybe I should have changed the other one, but either way. Let's try it again. Let's run the test. Right, so that works. Alright. So cool, so you see how that works. Yeah, there's one little trick to this that we don't really talk about that we should probably do. Did we have a conversation about it?
Make it ternary.
Exactly right. So I already wrote it. It's down here, and it uses your little trick there with the. So the way to avoid one of the so this is an object that's never null, and equal says one part of the contract with equals is if you ever give it a null, it returns false. So you are now outside of that situation. So this is essentially what you need. So first trick. Well, the first important thing is to use this rather long verbose syntax, but it actually works. And the only way to make this easier is to do a static import of true, and then you can just use true everywhere capitalized, and you're good to go. Okay. And everybody seems to be confused at that one. No? Okay, good.
Just one thing about this iteration. Compared with the readability, what do you think about it?
Yeah. All right. So the first things first. So if you do all the right importations, the static imports, it becomes very readable. But if you don't, then you can get to these very, very long.
I tend to use same ideas before, but you know when it gets long, not many people has such wide screens and people get crunch up.
Yeah. Yeah. I see.
So-
I agree.
Alan, I'd suggest showing what it looks like with the static imports. I think that will be more persuasive than asserting it.
Okay. So that require me to actually do some work, which I didn't sign up
Sorry.
for.
Would you like another piece
Click
of
on
pizza?
the true.
True.
See,
Is that how it works?
Star.
yeah.
Oh yeah, you're right. I should be able to do this. Is that right?
Oh,
No,
oh,
because
it's
You gotta do the
Packaging,
packaging,
Java.
yeah, Java dot.
Does that work?
There it is.
Yep.
And the same thing for option.
Yeah. Give me a second on the option one, because there's a little problem with that. Okay. So it makes it slightly more readable. So, who has ever seen this little bit before? You have? Carl? Where did that pop up?
I can't remember. I'm pretty sure I've seen it.
Yeah, this is the first time I've ever seen it actually come out anywhere, and it was kind of a surprise. It has, one of the reasons why this is necessary is because the type system in Java just simply isn't strong enough to really understand what's going on. So sometimes, even if, so in this particular case it would actually be fine, but this none, which does not have a string, still gets typed with a string. And the same thing over here. Now, I could do this without these, the types here. It would issue a warning, but you could also just do the option without the string and it would still work. Of course, then when you pull out the value, you'd have to type cats to make sure you get the right value. Java just does that behind the scenes. Is this prettier, easier to understand? That's a matter of taste, I think. Has anybody ever had to do this? No. It's a strong indication that we're sort of on the cusp of what the language can do. Right? That we have to use some very specialized syntax to make it work. So, go ahead.
So could you static import some and none?
I can import, yes, I can.
And I think I mean, yes, you get the warning, but it looks even cleaner.
You should be able to click on it and do Control 1
I should be able to do, yeah, but that's the other problem. You don't really get, let me just try this. You don't,
It doesn't feel as painful.
Dot star.
this. And then I should be able to do now, so, yeah, this will be interesting. I think I tried some of this. Don't think, there is a problem why this doesn't work.
Yeah.
Let's just try it.
Huh.
That's what I thought. The problem is that none is not, it's static, but it's not really, let me see if this will work.
Did you put the string or type in front of it?
It should be there. Does that work?
Maybe you need the string in front of it.
Yeah, then maybe, because then now you have to cast, no, I remember why, it's because now you have to cast it, otherwise it complains. So now you have to do this instead, which is pretty silly.
Oh.
And you still have to do the option, but
The norm is a method. I don't think you can import a static method. think the non is a method. You cannot import the static
right.
important method. You can only import a variable.
You can import methods.
Has to be public.
Yeah, but it has to be on something before you can use it, right?
Yeah.
That's the problem.
I think it really, I mean, it really is the type thing you were saying was that it doesn't know what the type,
Yeah,
what
'cause
the,
I
it hasn't classified the generic type that it's returning,
Right, so, let's see, option one.
which you might be able to do with just the string brackets.
In front of
Sure.
numbers.
You think so? Like this?
No, take away option,
Yeah.
Like
and
this?
the other option as well.
Yeah.
This one?
No,
no,
after your string. Between string, yeah.
Keep the dot.
Really?
No, not the dot, I'm sorry.
Yeah, I
Okay,
don't think
no,
so.
it's
I
not,
don't know that is syntactically not gonna work.
yeah, okay.
Alright, but the other stuff works, so. I spent some time trying to get this type system to do what I wanted, but, yeah.
Sorry, Alan.
That's all right. That's why we're here. All right. So, so you get an idea for how you build these things up to use options to return something when you may not have something to return. And if you use this consistently, you won't have any more of those null pointer exceptions. All right, back to the presentation. So, the other thing in functional programming is this idea of non-mutability, that we kind of tend to stick to stuff that doesn't change, because it has the nice property that you can reason about it very easily, and also you can do, you can have multiple threads running at the same time against the data without worrying about somebody changing something on you. You don't have to worry about metaphors or logs or sorry, not metaphors, semaphores or monitors or any of that sort of thing, because the data never changes when you're good. But even in single-threaded programs, sometimes we run up against problems. So this one was inspired by a class at Coursera, where they sort of showed what is the problem with mutable data in Java. So if you read this stuff, or if you read this, take a couple of minutes to think about it, and then figure out what is the problem. And this is real code. This was, I mean, obviously adapted, but this was a real problem that occurred in a real Java project.
So not like dot at the top, or assume that there's like a new in there or something?
There's a list in there. Assume that there's a list of users.
You can modify the list.
Very good, right? So, but I'll let everybody else sort of think about it for a second.
I didn't hear what you said, so.
Okay, so, but we'll think about it for a second. So,
So why are you calling get current user every iteration?
this is what the code looked like.
Okay.
This is how it's done.
Yes.
So,
Current user could change and.
you could. So, yes. So, but that's not in.
Anything could change.
Yeah, exactly. Well, you couldn't change the current user, but you can change the list of allowed users. So, the problem here is,
This
Then-
is multi-threaded, you said?
nope, single thread.
Single.
So in this case, I could just make a malicious user, me, and then I can just get the list of allowed users, add myself, and now I can use the resource. Ta-da. Think about this, like every time that you have an object inside of a class that somebody can get, they can change it. How many programs out there are you handing out references to objects that some other part of the program can use and then change as they like?
Way too many.
Yeah, exactly. So let me what we're gonna do. Let me go back here for a second. Java's first line of defense on this one is to make them final. Right? Does that solve the problem?
Nope.
Not one bit. Right? Because what they're making final is the reference So that's the problem. The solution to this, so the one that's mostly advocated is this defensive copying. You don't actually hand out the list that you have, you hand out a copy. Not only do you have to remember to do this, right? It's expensive, or potentially expensive to do this. There's a couple of people looking pretty confused right now. Does this not make sense?
Would you mind going back to the previous slide? So I'm looking at this code, and I'm not seeing any connection between this code and on the next slide when some more code appears.
Okay, so assume we have this class, protected resource, and we have an instance of it called a protected resource, and then you call the method on that, add another user to that collection, that list, and then you call use resource on that object.
Right, but if you go back to the previous slide, I don't see anything in that loop that's going to modify any of the data.
Nope,
Nope.
it's not.
The caller
You changed the
modified.
list before you entered the loop.
The object leaked
Yeah.
a reference to the object and the caller was able to modify it.
So the point of this whole thing is that you gave out a public reference to that mutable list?
That's exactly right.
Oh.
It's such a common thing to do that most people don't even think about.
And you could even have private final lists allowed users, and it would make no difference at all.
Does it make
There's
sense now?
collections.unmodifiable.
Yeah.
Yeah.
Mhm.
But then you couldn't change it, right? So if you did that, then you couldn't change it,
Right.
and now you have another problem. So, right?
Class that has a password for add.
Right, so, okay, I'll get back to that. Okay, so I remember, in a not too distant past that I was working on an Android program. It was an email program, and there was a list of emails. And guess what? That list of emails could get updated, from the server side at the same time the user was trying to sort it for date or sender.
That's awesome.
So, yeah, exactly, right? It's great. So this is not an uncommon occurrence, and even in a supposedly single-thread environment like this particular Android program, you're actually handing out the keys to the kingdom. Like, oh yeah, go change it on me. And it's a really bad situation. So, the solutions, you're still looking pretty confused.
I wouldn't say confused, I just think it's a poor example.
That may be the
Don't want
case,
people to
alright.
modify it, don't hand out a mutable reference to it.
Exactly.
And your Android example is a multi-threaded environment. You got Android, you got all sorts of things that can be happening in that environment.
This is true. This particular situation was actually, so this is true. Android generally, you can have stuff like that happen. In this particular case, it was the fact that you could have the user touch something at the same time. You could have the server do something, but only one of them was ever running at any one point in time. Doesn't change the fact. Right? A single core CPU. It can still happen.
So, yes, this is bad code, but it's the easiest code to write. It's very natural code to write. And it's very easy to write it and not see what you're doing. You think, well, I've got my thing, and somebody wants to see the list, so here's the list. You don't feel like you're giving access, giving away the keys to the kingdom, but you are.
You don't feel that way?
I do. But
I'm not really surprised by that answer either, because I know you.
But it's one of those things where you have to get bitten before you learn.
Yeah.
Right? So, and it's not, it's a known problem, right? But even seasoned security professionals where this example came from made that mistake. So it's not a zero event type problem. It happens. There is essentially three solutions, right? There's this defensive copying, which is you make a copy and you give that away. And you can make that non-mutable if you like. That's changing.
expensive and expensive.
Yeah. And then the other thing is you can implement methods like you were suggesting, right? Making sure that you can only change this,
Yeah, passwords.
on a certain set of circumstances,
Yeah.
right? Which in actual fact makes you replicate the list interface on the other class. Right? Now you have to be able to add, delete, all the rest of
I know. Make the list a protected resource.
it. Yeah.
Sorry.
Right. So the solution that a lot of people are now advocating is an immutable list, and that comes with another set of problems, which is how do you change an immutable list? So but I'll show you how to do that. So first of all, I want to, for those of you who's never been done functional programming, I want to sort of take your mind out of the programming world you're in and put it into the other one. The functional mindset is essentially the same thing as in math, and it's sort of like this idea: if you have 1 and 2, and you add them together, you get 3. It's sort of like 1 and 2 and 3 1 and 2 comes together and you get 3. And usually the syntax is like 1 plus 2 as in math, or if you're some programming languages, or however you want to put it, the semantics comes in to add 1 comma 2, and then that evaluates to 3. Now in the object-oriented syntax, we might do 1 dot add 2. Right? But the important bit here is 1 doesn't change. Like 1 is still 1. It doesn't become 3, because that would be bad. You get it? All right. So they've done this in Java. They did it for strings. So if we do something like new string equals old string plus more string, essentially they implement that as append, but this append doesn't actually change old string, right? It just says, take this string, append this, and give you back the full result. Right? The terminology, I think it's actually a badly chosen word, because it implies inside of your head, and I've been bitten by this, oh, I just appended something to the string I'm holding. But that's not the case. In fact, I remember some nights at a major company when we were doing a rollout, and this was exactly the bug that happened. And it was like, 11:55 at night, and we're trying to get this thing out, right? And for some reason, why doesn't the string change? Come on, there must be something wrong. And it's like, you look at it for 5 minutes, you go, of course, right? I use append and then not assign it back to the variable.
And it's very natural in languages where we use plus plus.
Yes.
To think, well, I call this and it changes.
Yes, unless we put, yes, I agree. So in go ahead.
Plus equal. Right?
Yeah, but that's an increment generally. That means that, and actually, that's a longer conversation, but it implies it's sort of an atomic operation. But let's leave that alone. So what we do is, so in Java, if you have a list and then you append, now append actually changes the list, which it doesn't do on string. Right? They should have chosen different words so that you can actually know what the right thing is. So of course, the question that I alluded to before was like, so how do you change a collection that's immutable? Right? And the short answer is, of course, you don't. So generally in these functionals, should we take a break at some point, or are we good for time?
We're now at 5 minutes.
Okay.
This is a good breaking point.
Yes, let's take a 5-minute bio break then.
Okay. So, bio break keys are in the back room. Please do not lock them or leave them in the back.